Okay, today I am going to show you an example of the maximum likelihood estimator. For this example, we are going to use the normal distribution as we see here for a random sample that we write here as x1, x2 to xn. In this case, the vector theta will contain two values. One will be the median and the other one will be the standard deviation, the variance of the normal distribution. Okay, for the maximum likelihood, we write the maximum likelihood for the vector theta that basically is equal to, we can write this in this way too, this, specifying the I1, I2, the x, x3, three values to xn, and this one basically will be the multiplication of all these x, right, in the function of the probability density function that we have for the normal distribution. Okay, so basically we can write this again in this way. Will be the multiplication of everything starting from the random sample 1 to the n of this function, which is this one, the variance here, and the exponent will be this. Okay, now what? Working with this multiplication is super hard. So what we can do is to make a transformation with the logarithm, the natural log, right? The natural log function is a one-to-one function, and it will go from also from greater to 0 to infinity, which basically map for the probabilities that we have here. So, and we will have some advantages of having this log function of the maximum likelihood. You will see in a moment. So we can call this function with the lowercase l of theta, basically will be the log. I am writing log here, but I am meaning log, the natural log. Okay, so we have the multiplication of all these values, and then the function to with this, the same function, the density probability function, like this. We remember that we have this property, right? A, B, everything that we have in a multiplication, we can write like this, plus log B, right? So because that, we can put everything that is inside in a summatory, like this. Okay, so now what? what should we do here? We can try to include this log inside of this multiplication also, and put these exponents in a side also, right? We can use because we have the log of a to b will be b log a. Okay, so on this part we know that this is also an exponent, right? So we can actually write this as 2 pi, right, elevated to something like this, multiplying by this, right? This part is something like this. So we can put this down because this is the log and this is a multiplication, so there will be a summatory. It will be a sum inside of the summatory. Okay, so we will have something like this. Summatory is negative here, right? Put it this, and then log, and the multiplication of right, minus because this one, so this is plus, but because this is minus, so we put minus half I minus the mean, right, log a, and this is 1. So what else can we do? We also have another property, log, right, will be log a log b, and we can apply this to here. So finally we will have something like this. Again we have half log 2 pi minus log sigma minus 2, this is the same, right? Okay, but the only one from all of these that have the x that have this is this one. Everything else is like a constant for the summatory, so we can move everything out just multiplying by n, right? And log 2 pi, right, and log sigma is 1 half multiplying the summatory and I1, right? Okay, now what we should do? We should get when we have the minimums, right? Because on the maximums. In this case, we have, because we have a vector of variables here, we need to have the partial derivatives for this. So we need, let's start with the partial derivative with respect to the mean. Okay, Okay. I have the derivative of this, the derivative of this, and the derivative of this. The derivative of all of this is basically a number, right? It's a constant. There is no u anywhere, so this is 0. This one is also 0 because this is n and log the another variable that is not the mean, so it's 0. The only one that we will get the derivative is this one, right? But how do we proceed for that derivative? Basically, we have this part is the constant, so we keep it, right? Multiplying by whatever is inside, we don't care, we just care about the summatory and these two. So we will have these two outside of the summatory multiplying, right, by the summatory of this that we have here, right, multiplying by the internal derivative, right, the derivative of whatever is inside, right? But again, this part that is inside, we can write this as a x, right, this minus u, like this, right? So this part it will go away, and this one will basically be the derivative. What is the derivative of this, right? So we have to multiply by the derivative, which is minus 1, this, right? Because this is just 1, so it go to 1, and this we keep it, and it is like this. So now what we should do, remember that in order to get the maximums or the minimums, I don't know if you guys remember, if we have a function, right, the derivative here and here will be 0, right? This is 0 here, and this is 0 here. It will be 0 for this point, right? This point. So we need to find this place wherever the derivative is 0. So what we are going to do is to make this equal to 0. And then this is what happened. If we have minus 1/2, okay, this half is going away, so sorry, this one is like this, we have the summatory xi xi u, right, equal to 0. But this is, we can multiply this by n, right? We have the xi is equal to n u, this one. This is a constant, it will go ahead, basically will be like this, and this we can change by that, and basically u will be equal to 1n, the summatory of all the random samples, right? And basically this is the formula, the proper node bias formula for this case is the same like the average, right? So what next? We need to continue for the other one. We remember that we have theta with respect to sigma, right? And again, the derivative of n2 log 2 pi with respect to sigma, this is the derivative of a constant, so it will go to 0, right? Minus the derivative of n log sigma with respect to sigma. We care about this, okay, minus the derivative of 1/2 summatory, right? All this with respect to sigma too. I have a hole here, so I will write it in this place. X sigma square. Okay. So now what? We will have this. This is easy, right? This is n. We have a negative here with the sigma in the denominator. The other one is not that simple, right? Basically, we will have 1/2 here, but again, this number will go down. Also, we will have this summatory here with the same thing. With respect to sigma, multiplying again by the internal derivative, which is also another summatory, again the same one, but this summatory will be only with the this will get as a constant, and we apply the derivative of a fraction here, so we keep the same sign that we have in the top for this one, and this one will be to the square. You know why we keep it this? Because this is a constant, this is a number just for the derivative, right? So this is basically sigma elevated to power -1, and this is power -2 with the negative here, right? So we have to put this negative somewhere, and this will be go away with this later. So at the end of the day, we have n, right? This 2 and 1 more, we have 3, right? Summatory, this will go away, and I1, and this is the same that we have here, so we can include in the same summatory to the square, because basically we are multiplying by the same thing, right? If we have this equal to 0, we can reduce this like this. 3 summatory 1 u to the square equal, because this is minus, we're going to multiply this one this way, right? Because I would like to have this alone in just one place, I can put this in the other side to multiply, and I move this down, right? So basically I will have 1 n U square equal to 3, and this is 2, and this will disappear. So basically my maximum likelihood for the variance will be and this is okay if we have working with the full population. However, because we assume at the beginning that this is a random sample, basically we remember that the variance, the random sample, is n-1, something like this, right? So what is the meaning of this? The meaning is that the maximum likelihood is biased. It's not the same of the same formula. So it is not like the previous one, which is unbiased. This is biased, but this is the maximum likelihood basically of with respect to the variance of the normal distribution. I hope you guys enjoyed it.